Hi, boys and girls. Today I'm going to have you look at the Stemscopedia article to really get some good ideas about what kinetic energy is. So I want you to go to this section called What Do You Think? And it's called Everyday Life, Energy and Roller Coasters. If you haven't started your engineering project, that's okay. But this paragraph is really going to help you understand how it functions. So it says, is the mass or the speed that causes the change? So how does the change in kinetic energy occur? Is it the fact that the object is heavier or the fact that the object is moving faster? So what parts play a role in that? Mechanical energy is a part of everyday life. So engineers who design roller coasters must understand the relationship between potential and kinetic energy. For example, engineers take advantage of potential energy when the coaster car is at the top of the roller coaster's first hill. This is usually the highest point of elevation on the coaster. Therefore, a car at this point has the greatest potential energy. It means it has the capacity of motion. It's just not currently in motion. It's currently stopped. So it has zero kinetic energy. As the coaster car rolls down the hill, its potential energy is converted to kinetic. At the bottom of the hill, the car's velocity is very high because it has a lot of kinetic energy, which propels the car up to the next hill. As the car climbs the hill, its kinetic energy is going to decrease because it's slowing down. So here's the image that we wanted to show you. And when we're talking about the word relationship between potential and kinetic, I want you to decide which one's high and which one's low and where are those located. So the very first initial drop has high potential, but zero kinetic because it's not yet moving. At the bottom, it has very little potential, like it's probably not going to go that motion any longer because it's at the bottom, but the maximum kinetic because that's when your speed is going to be the fastest of motion. Then as it climbs up, the potential energy is going to increase again as a pattern, and the kinetic will be decreasing because of the speed slowing down. So you can see the relationships. One's high, one's low, depending on what's going on. And then you're going to answer these questions. So I want you to look at these objects. We don't know what they are. They're just labeled A, B, C, and D. They have different masses. And then the kinetic energy is measured in a unit called joules, Joules. So it's asking you, as the mass increases, what happens to the kinetic. So look at the mass and see the direct relationship to kinetic. So you're going to have to describe these numbers and this data. And this is objects that are traveling. They have a velocity of 2 meters per second. So they can go 2 meters for every 1 second. Answer these questions. And if you have questions, let me know. But hopefully we'll go over these together on Tuesday for our science lesson because it really does relate with math about stuff we've been looking at with graphs and things. If you're wondering about the question that says describe the relationship, that just means describe what's happening with speed and what's happening with kinetic energy. Are they related somehow? Does one go up as the other decreases? Or maybe they both increase together simultaneously? Describe what's happening with the numbers. And then the last one just asks you to use your knowledge of kinetic energy. Explain why car crashes with high speeds have more danger than low speed car crashes. So kind of explain the effects of those. A lot of this might be common sense of something that you already know, but you're welcome to use the resources that we provided to research for you a little bit more. Do your best to answer the questions, but don't forget to log into StemScopes and see if you do have any assignments ready to be turned in. I think that's about it for kinetic and potential energy. And we will talk to you later. The most important thing is to reread and take your time.